Hello everyone, I am Shigen Shimojo. I will talk about how working memory influences knowledge reconstruction in collaborative learning, investigation using human experimentation, and actor simulation. The efficacy of collaborative learning is that learners can create a new knowledge by integrating others' knowledge with their own. Integration of others' knowledge aligns with the interactive in ICAP theory for promoting performance. A study found that using concept map can facilitate this process. However, it is indicated that there is an issue in collaborative learning. Integrating others' knowledge requires cognitive load. Cognitive load limits working memory capacity. It is difficult for learners to consider the perspectives of others. Considering this previous study, research question is that does working memory affect the process of integrating knowledge with others? The goal of this study is to examine the influence of working memory on integrating others' knowledge with their own knowledge using model-based approach. The reason of using the model-based approach is manipulating working memory and knowledge integration can be difficult in laboratory experiments. In the hypothesis of this study, H1 is that there is a relationship between working memory and the correct use of knowledge. H2 is that working memory influences the integration of one's own knowledge with the knowledge of others. Learners read an episode individually. That episode is that a student talks about the reason why he is anxious about the new semester. Next, learners infer whether it is external, stable, unstable, controllable, or uncontrollable, based on the causal attribution of success and failure. Finally, learners draw their inferred thought and knowledge on the concept map. In collaborative learning using concept maps, learners create concept maps collaboratively. Learners refer to the concept map drawn by each other on the right side and explain their thoughts and knowledge to each other on the left side to draw the concept map. We manipulate knowledge activation and the degree to which they use others' knowledge. In knowledge activation, we manipulated W. The W parameter was set to 0.71 and 1.3. 0.7 is low working memory, 1.3 is high working memory. In the degree to which they use others' knowledge, we manipulate utility. The utility parameter was set to from 8 to 12. 8 is low of degree to which they use others' knowledge. 12 is high of degree to which they use others' knowledge. We reproduced the experimental data to investigate the relationship between working memory and the number of correct links. As a result, there was a positive correlation between working memory and correct links. These results are consistent with those of the laboratory experiment. Next, we compare the number of reproduction to explore the relationship between working memory and memory retrieval based on knowledge of others and knowledge of others. The results show that the number of correct links in memory retrieval is not increased by integrating others' knowledge when the working memory is low. When working memory is high, the number of correct links is increased by integrating others' knowledge. Therefore, the effect of integrating is only when working memory is high. In the future, it will be possible to develop a learning support system using the cognitive model of collaborative learning. By having an agent equipped with this cognitive model, create a concept map and use it as a collaborative partner. We examined the effect of learning by teaching and being taught by partner peer tutoring. Thank you for listening.